Welcome to the third part of the MS portfolio. This episode is radicals and a bit of a part two on exponent law, specifically negative and fractional exponents. This one we have a lot to cover, so I'm going to take it pretty slow. I don't want to rush too much. But let's start off with just adding rationals and how to simplify rationals. To simplify rationals, you want to find the lowest multiple that fits in all of the terms. This second part doesn't really matter if you're just looking at one term, but since we're looking at a bunch, we want to find one that fits all of them. In this case, it's 3. 3 times 25 is 75. 25 is equal to 5 times 5. And it's the same kind of thing going down here. And so once we've finished these and all of these numbers here at the bottom, all of these numbers, I'm going to mark all of them. Can't be too safe. All of those numbers are going to be put into an expression here. So for this first term, we take our 3 and we multiply it by 5 and 5 again, which gives us 5 squared right there. Plus, here's our next term, 3 times 2 to the 4th, because there's 4 2's in this term. And then for this last one, we just have 3 3's, so it's 3 to the 3rd. And now, what we do is we look at our terms, and remember that there's an invisible little 2 on all of these. And we do some division, where 5 to the 2nd, to get it out of this, we can put 2 into 2 one time. So the 5 comes out, and then we are just left with our root 3. And then we have, for our next term, the same thing with our 2. And I do need to do a quick fix here. This is supposed to be a 4. Because we can fit 2 out of, or we can fit 4 into 2 twice. So 2 times 2 is 4. And then again, we're left with our root 3. And then for our last one, again, 3 fits into 2 one time, with the remainder just being root 3. And so we have 5 root 3 plus 4 root 3 plus 3 root 3, which is 12 root 3. Now let's look at simplifying them a little bit more and how it can be applied in different scenarios. Here we just have one term, and our area is equal to 675 square centimeters. And our area is also equal to our sides times our side, and that's just side squared. So we know that one side length is equal to the root a, which is the same as root 675. And it's just the same thing. We take all of these. And here we have a little bit more visual with 3 3's and 2 5's, where they get simplified into this and then pulled out to get our final answer. Now let's take a look at rationalizing the denominator. So when we look at this equation, we see this at the bottom with a root 3 plus root 2. And so what we want to do in this scenario is multiply by the conjugate, which, like, think of the difference of squares, where it's the same kind of thing, except this plus sign is a minus sign. And so we multiply by root 3 minus 2, or minus root 2, over root 3 minus root 2. We're multiplying this original expression by that. And in the end, that gives us 3 minus root 6 over 1, which is just root 3 minus, or 3 minus root 6. And lastly, we have our negative and fractional exponents. Firstly, with the fractional exponents, the way I like to think of it is that the denominator of the exponent just goes to the root. Like, say, if this was 2 over 2, it would just be the square root of 32. And we'll get to this in a second. We take the numerator, and I like to think of it as it kind of just holds on to it when it's in the root. And we can think of this the other way as well for something like root 3x to the 5th, where 3 is 1 over 2, or 3 to the 1 over 2 is how we see it in here, with the imaginary little 1 here and the imaginary 2 here. And you can see with the x, we keep the same logic, where it keeps the numerator and the denominator just goes over here. For negative exponents, the way I like to think of it is just finding the reciprocal of the positive exponent. So you take 3 to the positive 2, which is 9, and then you find the reciprocal, which is 1 over 9. And of course, you can still think of that the other way around. 1 over 49 is equal to 7 to the negative 2. And what we can do, we might not want to, but we definitely can, is with a bit of a mix of the two in this expression here, where we have 18y to the 4 over 3 times z to the negative 1 over 3 over 24y to the negative 23z, or negative 2 over 3, not 23. So what we want to do to solve this is we want to flip the negative exponents using this same exponent law that we see here to move our negative exponents to the other side of the expression. Like with this z here, we take it from the numerator to the denominator here, and we just get rid of that little negative, and you'll see the same thing with this y to the negative 2 over 3 gets put into the numerator, and we take away the negative. Now what we can do with this is we can use the exponent law to simplify our expression. We take out the 18, and we just multiply y to the 4 over 3 by y to the 2 over 3, which is, of course, since we have a multiplication sign and the same base, we can just add these two numbers together. And that's also because we have the same denominator here. But we add them together, and we get 6 over 3, 18y to the 6 over 3, which is just 18y squared. And then we're almost done. All we have to do is remove the common factors, and we're finally left with 3y squared over 4z to the 4 over 3.